function, right? Y equals x squared. So we are adjusting what does A, what does H, and what does K do. If they ask you if H is positive, what are we supposed to do? So what I would want you to do is I want you to put in here Y equals, and just pick a positive numbers. Oh, I didn't mean to make Y capitalized. Y equals, and pick a number to go where A goes. That did get wider, but it's still pointing what? Upward. What if I make it a decimal? I mean, they got more narrow. Now it got wider, but it's still doing what? Pointing upward. Well, if they ask me what happens when it's positive, well, guess what? If I really want to check, why don't I type in a negative number and see what's different? And now what happens? It opens downward. So by doing that, I've decided A makes it, if it's positive, point up. If it's negative, point down. All right, now let's see. Let's leave A what it was. And let's put in a positive H value. So it has a minus sign. What if I put a positive 3? What happened to the graph? The blue one.
Wait, where's the minus?
But the formula has minus in it. So if the formula has minus, the number behind it would be a positive 3. If I put a minus minus, then it would become a plus. And I know that that is very confusing. If it was plus 3, then it technically would be a negative 3 because that would be a minus minus. But if I put in this 3 here, what happened to the graph? If it's blue, what happened?
It moved to the right.
It moved to the right. And if I change it to a negative 3, what happened? It moved to the left. Now I'm going to erase all that part and deal with the plus K on the end. So if I add a positive number, what happens? It moves up. And if I have a negative number, what happens? It moves it down. So you can use Desmos just to try a few things if you need to. So now what I want you to do is I want you to look at the next problem. And it says, in this graph pictured, what are these things? One thing I want to point out, this line right here is the y-axis, and this line right here is the x-axis. Those other grid lines, I just couldn't, really get them to go away. So you got to figure out, is A positive, is H positive, and is K positive? So just click yes or no beside it for what you think for that graph, not click circle.
So did it move up or move down?
I moved up because the original is sitting down here at the origin of it. So you see how that broke up the higher? Because you're always comparing it to the original y equals x squared. You can look back at number 29 for some help. Y equals x squared is all you're doing. All right, so first of all, what does A tell us? If it opens up or if it opens down? Which one does this parabola do? Opens down. So that means A would have to be negative. So is A positive? No. Because it opens down. So if you need to make yourself a note because you're going to go back and study, because it opens downward. You would not have to put that note on the test, but I just want you to know if you're looking back for your notes to know why we chose no. All right, and then H greater than 0. Did it slide left or right? Left. And in the original, it's minus. Well, minus positive makes it go to the right. So minus a negative makes it go to the left. So H is actually yes. And then, yes, ma'am.
Yes, why?
Because it moved left.
But it,
And when H is positive, it moves to the right.
but it moved to the left.
You're right. It should be no. I don't know what I'm doing up here, apparently. Thank you, Ashley. Like yesterday with Blaze. That wasn't paying attention to. And then K, up or down? The vertex for the original one is at 0, 0. Is this higher than that or lower than that? Higher, which makes it positive, and I am confident that this is yes. I think what I said about moving left contradicted what I circled. Yes. Questions there? All right, so here is what I am going to do. I'm going to give you 5 minutes. No, I'm not. We're going to move to the next page, looking at this paragraph about average rate of change, because it's very important. I have mentioned average rate of change to you once this year for about 2 minutes. So if you're like, Ms. Dix, I don't remember what this is, I get that. I'm not surprised. That's why I put it on here for us to go over. It says the average rate of change between two input values is the total change of the function values divided by the change of the input values. And you're like, what does that even mean? So let me explain it better in another sentence. In other words, it is the slope between two specific points. The average rate of change is the slope between two specific points. How do we find slope? I'm going to tell you what the points are. I'm sorry, I was talking. Say it again. Rise over run. And we also had a formula. Can you remember what the formula was? That was slope-intercept formula. What was the slope? Subtract your y's, y1 minus y2 or y2 minus y1, it doesn't matter, over subtracting your x's. So if you want to write the slope formula over here so you'll have it, it's y2 minus y1 over x2 minus x1. If you're like Ms. Dix, I thought it was y1 minus y2. That's fine. It really doesn't matter. What matters is that whichever one you put first on top, you put the same one first on bottom. It just means subtract your y's and divide it by subtracting your x's. That's what that big sentence at the beginning says when it says the change in the outputs divided by the change in the inputs. Change in y over change in x. Now, some of the things that they're going to ask you to find the average rate of change are not a straight line. And you're going to say, Ms. Dix, I thought we can only find the slope of a straight line. That's true. So that's why if it is between those two specific points, you would be finding the slope of the line that connects those 2 points, no matter what shape the rest of the graph was. Okay? So don't write this, but if you had something over here that was a parabola and I ask you for this point and this point, it will be what is the slope of the line that connects those 2 points. So let's look at 34. I'm going to do one for you to explain it, and then I'm going to have you try one. It says the table below shows the values of the function g of x. So the table represents g of x. And a second function f of x is x squared minus 3. Which function has a greater rate of change over the interval 1 to 3? When it's got that brackets and it says interval, it means when x equals 1 to x equals 3. That's what it's asking. So I just told you rate of change is slope. So you got to find the slope between the 2 points that have x equals 1 and x equals 3. So looking at this one right here, the point that has x equals 1 is 1, 9, right? And the point in the table that has 3 is 3, 17. So we're just looking at these 2 points. We don't care about anything else in that table for this problem. I've just got to find the slope between those 2 points. So we subtract the y's. So I do 17 minus 9, because that's my y's, over 3 minus 1. So what's 17 minus 9? 8. And what's 3 minus 1? 2. So 4 is the rate of change for g of x. I'm just going to write g of x beside it, because 8 divided by 2 is 4.
4 is the what?
Is the rate of change. We just found the slope between the 2 points that I circled. All right, now we're looking at f of x. Did they give us any points for f of x? No, which means we've got to find them. So there's 2 ways you can do it. You can type that into Desmos and click table and see what the point is as 1 and 3, or you could just plug in 1 and plug in 3. So I'm going to plug in 1. If I plug in 1, that's 1 squared minus 3. 1 squared is 1. 1 minus 3 is negative 2. So my point would be 1 comma negative 2. And then I'm going to plug in 3. 3 squared minus 3. Well, 3 squared is 9, and 9 minus 3 is 6. So there's my 2 points. I'm trying to find the slope between. How do I find slope again? y1 minus y2. So 6 minus negative 2 over subtracting my x's. 3 minus 1. And you can type that into Desmos. If you don't have your integer rules 100% down pat, my gracious, type it in. I'm going to give you the calculator. I want you to use it. So 6 minus negative 2 is 8, and 3 minus 1 is 2. 8 divided by 2 is 4. So the rate of change for f of x is 4. So which one has a greater rate of change? They're the same. But if one of them was 4 and the other one was 5, you'd say the one that was 5 was greater, right? The bigger number would be greater. So I'm going to talk you through what to do for 35 and 36, and then you're going to try it. 35 says, find the average rate of change for that function from x equals negative 2 to 5. What that means is using Desmos, you're going to put negative 2 in for x, and you're going to put 5 in for x, and you'll have 2 ordered pairs. And then you're going to find the slope between those 2 ordered pairs. On number 36, it says, what's the average rate of change of h over the interval negative 6 to 3? So on the graph, you're going to go to the point negative 6 and put a point. You're going to go 3 and put a point, and you're going to find the slope between those 2 points. So I want you to take a minute and try 35 and 36 on your own. You need to put parentheses around it because you're plugging in a negative. When you put in 5, if you put it in, it won't really matter. You could put it or not put it, and you'll still get the same answer because 5 is positive. It only matters when the answer is negative, and when the x is negative. You use Desmos and you type in the values for x.
Where do I find the value?
It's written right there in the problem. It says when x equals negative 2, so you plug in negative 2 for x. And then you plug in 5, and you get out a point, and that'll be 2 points, and you find the slope between those 2 points. You plug it in to find it. So negative 2 is going to be the x value, and whatever you get out when you plug in negative 2 is going to be the matching y value to that. And then you're going to plug in 5, and whatever you get out is going to be the matching y value for that. Ashley, just try your best. No, you should not give up. That would be the worst thing you could do. Well, not the worst thing, but pretty far up there. Just wait. I'll go over it. Do your best until then. Go to the next one and come back. All right, I know you might not be finished, but I want to show you one thing here. I've typed in the equation that they gave us on the first one I asked you to do. You have two options. You can plug those numbers in for X, or you can type it in and hit table, and it gives you the one. What was it, 2 or 1? I can't see. It was -2. So it gives you the -2 right here. So that's one of the points you need. And if it doesn't give you the other one that you need, which was 5, guess what? You can come right here and hit 5, and it'll give you the one that goes with 5. So by typing it in and going to the table, you can get the values that you need. But if you type it in for X, you'll get those same values if you do it correctly. All right, for time's sake, let's go ahead and look at this. Does anybody have a question about how I got that table right there to see our values? Because I want to make sure you know how to do that before I go any further. All right, so once you write down the points, you just got to find the slope between those 2 points. So you subtract the y's, 10 minus 17, over subtracting the x's, 5 minus -2. 10 minus 17 is -7. 5 minus -2 is +7. So you get -1. So you've got to find the 2 points, subtract your y's on top, subtract your x's on bottom. Yes, ma'am. It doesn't matter. What I do is I just label x1, y1, and x2, y2. But if you called the second one 1 and the first one 2, you'd still get the same answer at the end. It would still be -1. All that matters is whichever y value you put in first on top, you put the same x value that goes with it first on bottom. So like, see how I used 10 first on top for mine? 5 goes with that, so I put 5 first on bottom. If I had done it the other way, I would have got 7 over -7, which is still -1. No, it's not. All right, and then on number 36, it said from -6 to 3. So -6 was at -6, 2. And at 3 was 3, 1. That's my 2 ordered pairs. Since it's on a graph, can't we just do rise over run? You could say it goes up 1 over 9. But if you do the slope formula, you'd say 1 minus 2 over 3 minus -6. And you'd get -1 over 9. So -1/9 is your answer. I typed the numbers in the formula. One is the y value, 2 is the y value, so I subtracted them. 3 minus -6. All right, so turn to the back page. There's one more thing I want to show you. It'll be the last thing we do today. We are going to go down to number 38, and there's actually something wrong with number 38, so I want to fix it first. Number 38 says, an object is launched and follows the path of this equation. What is a reasonable domain? It's supposed to say, what is a reasonable range? When I typed it up, I put the wrong thing. Now, reasonable range. What that means is in a word problem setting, what is a reasonable range? Not of the whole graph. If you're looking at the whole graph, it's got arrows on the end, it's different. But we're talking about just this setting. So an object is launched and it follows this path. So just to show you what this is going to look like, and I'm going to put it in Desmos. But if it's launched, it starts here at time 0, it goes up, and then it goes down, right? We don't care what it does after it hits the ground because it's not going to drill a hole through the earth, right? So a reasonable domain for this situation is only the part that I've drawn here. We don't care about what the rest of the graph is doing. Does that make sense before I show you the graph in Desmos? So if you are launching something, it starts at the y-axis, goes up and then falls down to the ground. We don't care what it did before it started at the y-axis, and we don't care what it does after it goes through the ground. Okay? So I'm going to type this into Desmos. Go away. There we go. All right, so we got negative 16x squared. Remember in Desmos, we always use x. Plus 64x plus 80. And I can't see everything I need to see on this graph. So I'm going to zoom out some. But it says domain. Is domain the x or is domain the y? The x. So the first x value we care about is at time equals 0, because do we care what it was doing before it launched? No. So when we're looking at the answer choices, we're going to mark out E. I'm sorry, we're looking at range. I just switched to domain. Let's go to range. Sorry, range is y, so that's up and down. So we care about the highest point and the lowest point. Where does the highest point on the graph happen? In a quadratic. At the vertex. So we want to know what is the y value of the vertex. So I'm going to scroll and scroll until I can get to that vertex. And what is the y value of the vertex? 144. So that's the highest point. And what's the lowest point that this graph is ever going to reach for what we care about? 0. Because we don't care about after it goes in the ground. So which one of those has from 0 to 144? C. So the reasonable range is from the highest point and the lowest point that would be in that. But then it says what's a reasonable domain, and that's your x's left to right. Well, we don't care about before time starts, right? So our x value is going to be 0. And then how do we find the farthest right point? The other x-intercept. So when I go back to Desmos, the x-intercept happened at 5. So our reasonable domain is from 0 to 5 because we only care about that first quadrant for something that's being launched. Now, let me tell you, I'm not giving you homework over the weekend. However, I am telling you the other problems we did not get to will be on this test. So when you come in here Monday morning, if you have questions about any of the problems we did not do, I will tell you the answers to them. Okay? So if you want to look at those over the weekend and just do the ones that you're like, hey, I don't really know what's going on in this one, I need to make sure I ask Ms. Dix about that. All right, I hope you guys have a great weekend. We'll come back on Monday ready to take this common assessment.